right, hello, pre-calculus. Here we are with some supplemental notes. These should go fairly quickly. We're going to talk about some even and odd functions. And to start with that, to start us off, we'll actually talk about even odd, identities. So identities slash functions. All right, so we're going to use the calculator to do a little bit of a discovery here. And let's look at, we're going to be in radians. So there's that. I just clicked mode and making sure in radians. So I'm going to do the cosine of, I'm going to start with 1. Okay, so the cosine of 1 radian. Cosine of 1 radian, that value is 0.54. These are unfamiliar. Numbers, so we're just going to be looking at that. The cosine of 1 is 0.54. So what happens if I put in a negative angle? Cosine of, say, -1. Well, if you think about it, if you were dealing with the cosine of, say, a 30 degree, that would be in quad 1. If you were thinking of the cosine of a negative 30 degree, that would be in quad 4. Those are going to have the same sign. Now, this isn't a degree, this is a radian, but, just by my knowledge of degrees in quad 1 and 4, I'm going to guess that this is the same value, and indeed it is. This is going to turn into one of our identities. Okay, so those were the same. So I can make this conclusion. Therefore, the cosine of a positive angle in radians is equal to the cosine of a negative angle in radians. Those are equivalent. All right, let's think about sine then. If I put sine of, say, positive 3, I get 0.14. All right, so I'm going to think about again. I mean, I know this isn't 30 degrees, but if this were 30 degrees, sine would be in quad 1, and if it were negative 30 degrees, it would be in quad 4, and sine would have an opposite sign. Sine is negative in quad 4. So I'm kind of guessing that this is going to turn out to be negative 0.14, and indeed it is. So again, this is going to be an identity. So therefore, we can say that the sine of a positive angle is equal to the opposite sign of the positive angle. Okay, so those values were the same. These values we would call opposites. And that's what that negative is saying. You can probably guess what's going to happen with tangent. Tangent of the positive 0.5 is 0.55. And think about, if this were a 30-degree angle in quad 1, and then in quad 4, tangent would become negative. So this indeed becomes negative. Same value, but just negative. All right, so same thing. The tangent of a positive angle is equal to the opposite of the negative angle. So how do we write that? Like so. I always kind of think about when I'm writing the opposite ones, you got to have one will have an opposite in the parenthesis and one will have an opposite in front. One will have an opposite in the parenthesis, one will have an opposite in front. And if they're equivalent measures, then you just have a negative and it's equivalent to the positive version. So these are your even odd identities. Basically, it just says that the cosine of a negative angle, those values are the same. Okay, and so secant is going to do the same with as its reciprocal function. So secant is going to be the secant of a negative angle is just going to be the same thing as the secant of a positive angle. All right, so again, just looking here, again, if you had this as cosine of x or t, that angle's t. So cosine of t, sine of t. This is x and this is y here, right? If you drop this right triangle, this is x and this is y. And so if we go this way, this is same cosine, but this x and this y, this here, they're positive. But down here, they would be positive, negative. Okay, so that's why this stays the same, because positive and positive are the same. And then sine of t is the y value, so it goes from positive to negative. Same goes for the secant. All right. And then same goes for the tangent because it involves x and y. It's actually y over x. So this would be positive over positive, and this would be a negative over positive. So tangent of a negative angle will equal the opposite of the positive angle, and cotangent will behave the same. All right, so let's move on. Let's compare this to algebra. An even function has symmetry with respect to the y-axis. All right, symmetry with respect to the y-axis. Here's a perfect example. Okay, so negative x and f of x. Perfect example. So let's say this is a parabola. Y equals x squared, or f of x equals x squared. If I put in f of x, I get x squared. If I put in f of negative x, I still get x squared. No change. If I put in 2, I get 4. If I put in negative 2, I get the same thing. Okay, so anytime you put in a negative angle, you get the original. You get the function itself. And that's the definition of an even function. F of negative x equals f of x. In class, I kind of write it like f of x is f of x. No duh. And then when you put in negative x, you get that original. Okay, but this is how it's officially written. And they have y-axis symmetry, so this is the y-axis. And then an odd function has symmetry with respect to an origin. This is a rotation. This is a reflection. This is a rotation. Okay, and what happens here is you go like that. So you end up getting negative x, negative f of x. All right. And so what happens here, so for example, let's do f of x equals x cubed. So if I put in a negative x, I get negative x times negative x times negative x, which is negative x cubed. Okay? With a point, let's say you put in 1, you get 1 times 1 times 1. Let's say you put in a negative 1 times negative 1 times negative 1, you get a negative 1. So 1 with 1, negative 1 with negative 1. So f of x equals the opposite of the original. And that's an odd function. Okay, so again, I like to say with the odd functions, comparing it to right here, you know, a function is equal to a function. Function is equal to itself. But when I plug in a negative value, if I get the opposite of the original, then that's odd. All right? And so we're going to now classify our trig functions as even or odd. You can probably see where this is going. So f of t is sine. When I plug in a negative angle, it is going to, you're going to get this sine of negative t. And we've already determined that will be negative sine of t. So f of t is equaling the opposite of the original odd function. Okay, and that's symmetric with respect to the origin. So we are going to graph sine, and you are going to see it has a symmetry with respect to the origin. Let's just give you a little preview. Sine of x. I'm going to zoom 7 it so you can see it. And see, that is going to be the graph of sine. You're going to know how to do that on your own, and that's got symmetry with respect to the origin. If you did a 180 rotation, the graph would land on itself. All right, think about cosine. If I plugged in a negative t, I would get no change. So you plug in a negative t, you get no change from the original. This is even. Okay, this will be symmetric with respect to the y-axis. Okay, let's check that out. Cosine of x. Okay, there's cosine of x, and you can see you have y-axis symmetry. That's cosine graph. Like I said, you're going to be able to do this very soon. All right. The last question kind of does a mix, which is fun. So let's just see if this is even or odd. All right. So plug in a negative t and see what happens. This is the original. Negative t, that sign changes, plus cosine of negative t. Well, cosine of negative t is just positive cosine of t. That's going to be the same value. So this is going to be, this isn't exactly the same. T went to negative t. Cosine did not change, but the t changed. This isn't fractional, so I can't pull out a negative and make it be a negated version of itself. So this is neither even nor odd. And that's okay. That happens. All right. So I took the test. Hope you did well. If you're taking the test, good luck. And I look forward to seeing you guys in class. All right. Bye.